Okay, so to wrap this thing up, there's just one more concept that we have to make sure that we talk about, and that is the three types of solutions algebraically. We know that when lines are parallel, that they have no solution because they don't cross. But if we're not graphing it and we're not solving for slope intercept form and we're solving it algebraically, what does it look like? So I wanted to give you an example of what a parallel line looks like when you are solving it algebraically so that you will know what to expect when you're solving out the system and it comes out a little strange. So the example that I'm going to give you is negative 12x plus 6y equals 66. And the other equation is y equals 2x minus 5. Now, just by looking at the system without really analyzing it 100%, it just looks like a basic substitution system. And the reason why I want to substitute is because one of the variables is already in x or y equals form. So this is a setup for a substitution method. I don't really know that they're parallel yet. I don't really know that they have no solution yet, but I will in about 3 seconds. This is really fast, but you have to make sure you understand and be able to analyze how to get your results and what to do with it. So I'm going to take what y equals and I'm going to substitute it into this y position. I'm going to rewrite my first equation and I'm going to substitute that 2x minus 5 in. So I have negative 12x plus 6, and then in the parentheses, of course, because it's a multiplier, is 2x minus 5, and then equals 66. So this is just substitution method. We've already practiced this today, and now we are going to see what happens when there's no solution. How does it look? How does it come out? We're going to bring down that negative 12x. We're going to distribute that 6. So I get plus 12x minus 30 equals 66. At this point, I have negative 12x plus 12x, and we can combine them. And when we do, they cancel. Negative 12x plus 12x is 0. They wipe out. And you're left with negative 30 equals 66. And everybody knows that negative 30 does not equal 66. So we need to put a not equal to. You got to put a line through that to indicate that you recognize that they are not equal. As soon as you get your variables are going to cross out, your variable will cancel, and there's an and. The constants don't match. They do not agree. Negative 30 does not equal 66. This means right now, this tells me algebraically that there is no solution to the system and that the lines are parallel. Parallel lines are the only ones with no solution because that means they can't touch. The second type of lines that we have are called coinciding lines. Coinciding lines are lines that lie on top of each other. They're literally identical lines. And you would think that you would be able to identify when lines are coinciding, but sometimes when we're in it and they're telling us to solve using substitution or elimination method, we don't recognize that. Plus, we have to show our work. And the example that I'm going to show you for coinciding lines, but this time I'm going to have it set up for elimination method, you'll be able to see what it looks like and how to handle it. I'm going to pick a different color pen here. Let's go darker blue. This is 2x plus 10y equals 90, and x plus 5y equals 45. Now, if I'm just looking at these and it says solve the system using elimination method, we're going to know that elimination is a great method to use because everything is lined up. And what we need to do is go about our business and do elimination method, but with the understanding that now that I've already spoken about it being coinciding and that they're going to have infinite solutions, what does the algebra look like so that you'll know? In this case, I like to eliminate the x's. So what I'm going to do is I'm going to make two big parentheses for distributive property, and I'm going to swap. Now, this is really a 1 in this spot. So I'm going to put the 1 up here. I'm going to put the 2 down here. And because they have the same sign, right now they're both positive, I need to introduce a negative. So I'm going to introduce a negative on the bottom one. So when I do this, I'm going to make two brand new equations. Well, kind of. The top one, I'm distributing the 1 and nothing happens really. We're just going to rewrite it. 1 times 2x, 1 times 10y, and 1 times 90. And the bottom one, I'm going to multiply everything across by -2. -2 times 1x is -2x. -2 times 5y is -10y. And -2 times 45 is -90. Remember that when we're doing elimination method, after we distribute everything out, what I'm looking for is for my x's to have the same coefficient with different signs. Once I have that, I know I'm going to add down. When I add down, positive 2x and -2x cancel. 10y plus -10y cancel, and 90 plus -90 cancel, and you're left with 0 equals 0. There's nothing left on the left side, there's nothing left on the right side, and you end up with agreement. So you will be coinciding when your variables will cancel out. And the constants will agree. And I say that because if you do a coinciding line equation by substitution, instead of getting 0 equals 0, you might get 5 equals 5 or -3 equals -3. But they have to match. They have to agree. As soon as your variables cancel and your constants match or agree, that means that you have infinite solutions and your lines are coinciding. I did it again. If you have questions, rewatch the video or contact your teacher.